Hi students, today we will discuss a problem on matrices and determinants which is given in Advanced Exam 2025 from paper 1. Now coming to the question, consider the matrix P equal to 2 0 0 0 2 0 0 0 3, comma, let the transpose of a matrix X be denoted by X transpose, then the number of 3 by 3 invertible matrices which means determinant not equal to 0 of Q with integer entries. All the entries should be integers such that Q inverse equal to Q transpose. So in that concept, Q inverse equal to Q transpose, we can say that Q into Q transpose equals to I, or Q transpose into Q, that is equals to I, which means that Q is an orthogonal matrix. So in the orthogonal matrix, if you observe that orthogonal matrix, the determinant is always equals to either plus or minus 1, right? Now in this question they have given P and the unknown is Q. Now we need to find the value of Q, but they mentioned clearly that PQ equal to QP. So that I just consider Q is a matrix that it is A, B, C, D, E, F, G, H, I. It's a 3 by 3 matrix. So that by using this condition that PQ equal to QP, just try to multiply. P is 2 0 0 0 2 0 0 0 3 into Q A B C D E F G H I, which is equal to A B C D E F G H I into, this is what, 2 0 0 0 2 0 0 0 3. Now after multiplying the left hand side, what we will get is it's 2A 2B 2C. Now second row 2D 2E and 2F. Now coming to the third row, it's 3G 3H 3I. That is about the left hand side. Now move on to the right hand side. It's 2A 2B 3C. Now 2D 2E 3F. Next 2G 2H and 3I. Now compare the left hand side and right hand side. If you observe that first elements, that is 2A 2A, that will be same, 2B 2B same second element, but the third element here is 2C, but it is 3C. If the entries are integers, but when you observe 2C equal to 3C, then in only one case it is possible, that is C equals to 0 because of integer entries. 2C equal to 3C is possible when C equal to 0. Then next here 2F and here 3F, so that F equal to 0. Now 3Z 2G, so that G equal to 0. 3H 2H, so H equal to 0. Then these four elements are 0. Now coming to the matrix Q, that is there is no change in A, B 0, D E 0 0 0 I, right? This is about the final matrix Q, and they have given one more condition that it has to satisfy that Q into Q transpose equal to I, which is given Q inverse equal to Q transpose, right? By saying this, A B 0 D E 0 0 0 I into A B 0 D E 0 0 0 I is an identity matrix. A 3 by 3 identity matrix is like this. Now multiply and compare the right hand side, so that what we'll get is, here the first value is a square plus b square, and AD plus BE 0. Same, this one AD plus BE E square plus D square and 0. This one 0, 0 and I square. So that it is 1 0 0 0 0 1, right? If you compare, what we are observing is a square plus b square equals to 1, AD plus BE equal to 0, and E square plus D square is equals to 1. This is what we have to observe. Now from this, a square plus b square equal to 1, AD plus BE equal to 0, E square plus D square equal to 1, right? Now keep something in mind that a, b, c, d, whatever may be the values here, all are integers. Then if a square plus b square equal to 1, there will be a cases that a equal to either plus or minus 1, so that b equal to 0, either plus 1 or minus 1, b equal to 0. Then in case of a plus 1, b 0, a here if you substitute 1, either plus or minus 1, if b 0 means it has to be 0, then I can say that d is exactly equal to 0, right? In case of d equal to 0, then this quantity will become 0, and anyway b, this quantity will become 0, so that this will satisfy. Then d equal to 0 in this case, so e square equal to 1 means e equal to either plus or minus 1, so that here there will be total, if you observe, plus or minus 1, b0 d0 and e equal to plus or minus 1. So a1 0 0 1, like 1 0 0 minus 1 minus 1 0 0 1 minus 1 0 0 minus 1. So like this, here we have 4 cases. Including this, there will be a last condition that I square equal to 1, which means I equal to plus or minus 1. So that total 4 and I equal to plus or minus 2 cases. So this will be possible in total 8 cases. After that, reverse, which means a equal to 0, b equal to plus or minus 1, same, d equal to 0, b equal to plus or minus 1, b equal to plus or minus, then for suppose so if you observe clearly, so here total 8 cases, plus or minus 1, b0 d0 and e plus or minus 1, I equal to plus or minus 1, and the rest of the cases here, where here these two b and d will become plus or minus 1, a and e will become 0, I equal to plus or minus 1. Here we have total 8 cases. So in case 1, total 8 possibilities, case 2, total 8 possibilities. So total invertible matrices of Q is equals to 16.